The vanishing stars. A universe beyond reach. A vast and seemingly infinite universe has always held mysteries that stretch the limits of human understanding. For centuries, we've gazed into the night sky, wondering about our place in the cosmos and what secrets lie far beyond the stars. With every new telescope, every scientific advancement, we have pulled back the veil just a little more. Yet the deeper we look, the more complex, beautiful, and sometimes terrifying the universe becomes. Recently, astronomers using the most sophisticated instruments in history made a discovery that defies explanation, a phenomenon so perplexing it may shake the very foundation of modern cosmology. The James Webb Space Telescope, humanity's most powerful eye on the universe, has detected something truly astonishing: the sudden and unexplained disappearance of an estimated 900 trillion stars. No supernovae. No fading light. Just gone. This baffling cosmic event raises urgent questions. Where did these stars go? Are we witnessing a rare natural event, or is this a sign that our understanding of space, time, and the universe itself is fundamentally flawed? The James Webb Space Telescope, or JWST, was launched with a mission to explore the farthest reaches of space and time. With a staggering budget of $10 billion and decades of development, its goal was to peer deeper into the past than ever before by capturing light that has traveled for billions of years. And already, its capabilities have far exceeded expectations. Compared to its predecessor, the Hubble telescope, James Webb operates in the infrared spectrum, allowing it to see objects hidden behind clouds of gas and dust and to capture faint signals from galaxies so far away. Their light has been stretched by the expansion of the universe itself. In July 2022, JWST began scanning long-wavelength infrared light, specifically redshifted ultraviolet radiation light that has been stretched as it travels across the cosmos. This light comes from ancient galaxies, giving us a glimpse into the very early universe, just a few 100 million years after the Big Bang. These observations were supposed to help us understand galaxy formation and star birth. But instead, something unexpected happened. What the telescope saw, or rather, what it didn't see, shocked the scientific community. Entire regions that were once teeming with starlight appeared to be empty. Stars, trillions of them, were simply gone. This startling observation has led scientists to propose two competing theories. The first theory is somewhat optimistic. It suggests that these stars may still exist, but their light has been obscured. They might have dimmed drastically, perhaps hidden behind clouds of interstellar dust or gas. Or they may have collapsed directly into black holes without producing the massive explosions, supernovae, that usually accompany stellar death. If so, we might still detect their gravitational influence or radiation in different parts of the spectrum. The second theory, however, is far more disturbing. It posits that the universe's expansion, driven by a mysterious force known as dark energy, is accelerating so rapidly that these stars have crossed a cosmic boundary. A point of no return, where light from those stars can no longer reach us. In essence, they still exist, but as far as we're concerned, they are now beyond the observable universe. The universe, as we've long known, is not static. Since the early 20th century, scientists like Edwin Hubble demonstrated that galaxies are receding from us. And not because they are moving through space, but because space itself is expanding. This concept forms the basis of the Big Bang theory, that all space, time, and matter originated from a single, incredibly dense point. But even more unsettling is the discovery made just a couple of decades ago: this expansion isn't slowing down. It's speeding up. Something we still don't fully understand is pushing the universe apart at an ever-increasing rate. This force, dubbed dark energy, now dominates the universe, accounting for nearly 68% of its total content. It acts in opposition to gravity, causing distant galaxies to accelerate away from us so quickly that one day, they will vanish from our view entirely. And that day may be arriving faster than we. Redshift, relativity, and the race against time. To understand what's happening, we need to dive deeper into how we observe the cosmos. When we look at a star that's 100 light-years away, we're not seeing it as it is now, we're seeing it as it was 100 years ago. Light takes time to travel. So every glimpse into space is also a journey into the past. But things get even more complicated on a galactic scale. When we observe a galaxy whose light has traveled for hundreds of millions or even billions of years, the galaxy is no longer at the position we're seeing. Due to the expansion of the universe, it's now much farther away than the distance that light represents. This effect is called cosmological redshift. As light travels through the expanding fabric of space, its wavelength stretches. What begins as ultraviolet or visible light arrives at our telescopes as infrared. The greater the redshift, the farther and older the source. And with James Webb, we're seeing redshifts greater than ever recorded. The massive redshifts detected by JWST confirm that the universe is not only expanding, it's accelerating. And that acceleration has a profound consequence. Eventually, distant galaxies and everything in them will become invisible to us, not because they cease to exist, but because the light they emit can never overcome the expanding space between us. There is, quite literally, a horizon beyond which we cannot see. A boundary where the expansion of the universe is faster than the speed of light. Beyond that boundary, photons, even those emitted right now, will never reach us. This means that of the estimated 2 trillion galaxies in the observable universe, only about 6% are still accessible to us. The rest are already beyond that limit, drifting further away with every passing second. And this number is shrinking rapidly. In fact, it's estimated that between 20,000 and 60,000 stars become unreachable to us every single second. The light they emitted just moments ago is still on its way, and we will eventually receive it. But from this moment forward, any new light they emit will never be seen on Earth. It's a humbling, almost haunting truth. We are watching the universe disappear before our eyes. Not because it's dying, but because it's expanding faster than we can ever keep up with. The observable universe is currently about 93 billion light-years in diameter. But due to this relentless expansion, there are vast regions of space that are already permanently out of reach. Even if we could travel at the speed of light, the fastest speed allowed by the laws of physics, we still wouldn't be able to reach them. So what does this mean for humanity? It means our cosmic neighborhood is shrinking. In the distant future, only galaxies gravitationally bound to the Milky Way, such as Andromeda and its satellite systems, will remain visible. Everything else will vanish from view. If humanity ever hopes to explore, communicate with, or understand galaxies beyond our local group, the time to act is now. Every passing second is another missed opportunity. Every star that slips past the cosmic horizon is a piece of the universe we may never study again. Unless we discover revolutionary ways to manipulate space and time, perhaps via wormholes, warp drives, or quantum shortcuts, we may one day find ourselves stranded in a cosmic archipelago, isolated by the universe's relentless expansion. The James Webb Space Telescope has opened our eyes to the deepest truths of existence. It has shown us not only where we came from, but also what we stand to lose. In doing so, it has redefined our relationship with time, space, and the stars. And though the future may seem uncertain, perhaps this knowledge is also a gift. A reminder to treasure the fleeting light that still reaches us. To study, to explore, and to wonder while we still can. Because in this vast and accelerating universe,